Okay, hello everyone. Guys, today we're going to divide radical monomials. Okay, remember yesterday we multiplied them. Today we're going to divide them. All right, today's objective, again, to divide and simplify expressions involving radical monomials. Guys, and basically it comes down, the hardest part is to rationalize the denominator. All right, that's kind of what the simplifying also includes. Again, today's essential question: how do we divide and simplify radical monomials? When dividing radical expressions, again, use this quotient rule. And we've kind of used it before. Again, and today we're just going to work with square roots, where the n is 2. So we won't write it all. The index is 2, so most of them we won't even show it. Okay? Again, you can divide them or put them under the same radical. All right? You can have two separate radicals or put them under the same radical, either one. Example 1. Guys, these are under two separate radicals, but here we put them under the same one and just say, well, 100 divided by 4, that's 25. The square root of 25 is 5. Guys, we could also keep it separate and say the square root of 100 is 10. The square root of 4 is 2. 10 divided by 4 is 5. Either way works. Here's example 2, again, 24, the square root of 24 over the square root of 18. Here what they did is they put them both under the same radical, divided by 2, so it's 12 over 9. And again, the square root of 12 is 4 times 3. And the square root of 9 is just 3 on the bottom, okay? And the square root of 4 is 2. Again, 12 has a factor that's a perfect square. It's 4. So we can take it out. There's our final answer. There's example 3. Again, there's a 50 on top and a 2 on the bottom. So when we put them together here, we can just divide them. So now we just have 25. Now there are 5 x's on top. So when we put them together, guys, we can just divide it out. Again, 5 minus 1 is 4. That eliminates the entire denominator. And guys, 25 is a perfect square. It's 5. And x to the 4th, that's a perfect square. The square root is x squared. All right, example 4 is a little harder. Again, we have a numerator here and a denominator with two separate radical signs. But we can put them under the same radical sign. And 54 divided by 3 here is 18. And the nice thing about it, it eliminates the entire denominator again. There's 5 x's on top and 1 on the bottom. So when you subtract it, you have 4 left up top. There's 8 y's up top here and 3 on the bottom of the y's. 8 minus 3 is 5. So we end up with 5 y's underneath this radical sign. Now guys, 18 again is 9 times 2. The square root of 9 is 3. So the 3 comes out and the 2 stays in. The square root of x to the 4th is x squared. It comes out right there. There's no x left inside. But the y here, there's 5 of them. And because that's an odd number, we're going to take 4 of them out. So outside it becomes 2 y's, y squared. And inside there's still 1 in there. So underneath the radical sign, all that's left is 2y. All right, it's a little more complicated problem. In order to simplify a radical expression, to have it truly considered simplified, there's some things that it cannot have. It cannot have a radical in the denominator. You can't have a square root type sign or a cube root sign. You can't have a fractional exponent in the denominator. And those two things, they kind of mean the same thing. All right, you can't have a fractional exponent in the denominator. And you can't have a negative exponent at all. If you have a negative exponent, then on the top, put it on the bottom. If you have a negative exponent on the bottom, then put it on the top. Okay? Guys, now sometimes if this situation occurs, we must multiply the entire expression again by some form of 1 to eliminate that situation. And this process is called rationalizing the denominator. We did this already a few times. We're going to work on it here some more today. Guys, we're going to rationalize a simple example here. 1 over the square root of 3. We looked at this one before. I had it on the board. I multiplied the top and the bottom here by the square root of 3. So our final answer, the top becomes the square root of 3, and the bottom is the square root of 3 times the square root of 3. Well, that's just 3, okay? Here's another example where we have the square root of 2x underneath. So I'm going to multiply the top and the bottom by the square root of 2x to get rid of it. All right, so the top becomes 6x. All right, because 3 times 2 is 6. The square root of 6x. And the bottom, again, just becomes 2x. And we've gotten rid of the radical. That's what we're trying to do here. All right, here's a little more difficult example. Again, we have a square root here. There's a 4 on top. So guys, that's a perfect square. Right here, we can take it out. It's a 2 outside. All right, there are 11 a's. I can take out 10 a's. Outside, it becomes 5 a's. And we leave 1 inside. Again, inside, you leave either 1 or none inside a square root. All right, on the bottom here, b to the 13th, I can take out 12. 12 is a perfect square. Outside, it becomes b to the 6th. And c to the 7th, I can take out 6 of them. Outside, it becomes b to the 3rd, b cubed. All right, I leave 1b and 1c inside. Ooh. All right, but we got to get rid of that, the square root of BC. That's what we got to get rid of. So we multiply the top and the bottom by the square root of BC. So the bottom, again, will be b to the 6th, c to the 3rd, and then BC. All right, so now we have 7 b's. I write the 7 b's here, and we have 4 c's. I write the 4 c's here. The top now has a, b, and c underneath the radical sign. All right, again, it's a kind of a complicated example. It's okay. I want to show you something that's a little harder. Like the last example, guys, is going back to a very simple one. All right. This is the square root of 7 over x. We have to get rid of the square root of x underneath. We have to get rid of the radical in the denominator. So multiply the top and the bottom by the square root of x. So the bottom just becomes x. And the top, the x is joined inside the radical sign with the 7. All right, guys, that's it. Let's see, I'm not going to call it a homework check. I'm going to call it a warm-up. All right. All right, guys, what's today's essential question? And the 3 things a simplified radical expression cannot contain. All right, that's it, y'all. Thanks.